If you put Betelgeuse where the Sun is, it would extend to the orbit of Jupiter, a monster totally shaky and going to explode. It is among the most prominent sources of radio energy in the entire universe, delivering more energy than a billion suns. Betelgeuse, or Betelgeuse, is a red supergiant star. In the event that you put it where the Sun is, it would connect with the orbit of Jupiter. Monstrous, completely unpredictable, and also likely to explode. When we consider stars, we most likely imagine small glowing things in the night sky. Basically, this is the way we see them from down here on Earth, yet stars are something completely different. In fact, one of the most prominent stars, Betelgeuse, is much greater than our Sun. For many years, this star has confused scientists. However, something even more upsetting has been happening with Betelgeuse, making astronomers and other highly educated individuals incredibly concerned. Join us in this video as we investigate the marvelous news about Betelgeuse, its impending obliteration, as predicted by the James Webb Space Telescope, and how this new advancement will impact our universe and our lives here on Earth, as explained by physicist Michio Kaku. Betelgeuse is a massive marvel, a huge star that has interested cosmologists for such a long time. A Greek astronomer named Antonius was the first to discover this star is so giant that it can be seen in the night sky from Earth, particularly during winter. If you're into cosmology, you've probably seen or heard of the star. The reddish-orange star marks the upper left shoulder of the Orion constellation. So you see, the star is ancient and thus far quite possibly one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay consistent. Rather, it fluctuates. This change is one of the great properties of the star, but it isn't the only one. Let's investigate some of Betelgeuse's specific properties. The majority of the stars you see in the night sky are far from Earth. The nearest star is 4.2 light years away from Earth. In case you fail to recognize how the term light years gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It has been shown that light can cover a distance of 186,000 m/s. Thus, the distance light can cover in a year is comparable to 1 light a year. If you crunch the numbers, you'll get billions of miles. So when we say the closest star is 4.2 light years away, it means it is billions of miles from Earth. Now think about this. Some stars are much farther away, and Betelgeuse is one of them. Betelgeuse is found about 600 light years from Earth. So if you somehow manage to travel to it at the speed of light, it would still take 600 years. We can't move that quickly, not even our fastest space rockets can, yet this star can still shine so brilliant in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, that's due to its unique qualities like size and luminosity. Betelgeuse is multiple times greater than our Sun. Its radius is estimated to be on the order of 1,000 times that of the Sun. Tragically, it appears as a distant space when using modern telescopes, while various stars appear as small points of light. This is thought to be a result of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 by 10 to the power of 30 kilograms. Scientists can't determine the specific mass of Betelgeuse since there are no other planetary bodies orbiting around it to compare it with, and of course we can't measure it directly from here on Earth. However, this makes Betelgeuse at least 12 times heavier than our Sun. The brightness of Betelgeuse varies between magnitude +0 and +1.6. In simpler terms, Betelgeuse is many times more luminous than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay. Constant, it fluctuates. This change is due to its pulsations. As Betelgeuse expands, it becomes brighter. When it contracts, it dims. The cycle can last from 10 to 100 days or even significantly longer. A unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is far stronger than at the typical surface. However, the downside is that these strong magnetic spots interfere with the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots compared to our sun helps explain why it is cooler than our sun. Despite its size and brightness, the sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 10 times stronger than that of the sun. This field is the reason that when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be in circles or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the weak energy radiated by the star and its characteristic red hue. Betelgeuse is a red star, but it wasn't always red. Around 10 million years ago, it was yellowish. Much like our sun, over time the color began changing to orange-red, and then, around 100,000 years ago, it slowly started transforming into the red star. We know today this fact has led scientists to believe that the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the sun. It would have been a fierce contender to our sun if it weren't so far away. The fact that Betelgeuse, which is 600 light years away, can still be seen with the eye around nighttime is quite striking. Our sun is only 8.3 light minutes from Earth, which is why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime, but if it were to replace the sun, it would consume or displace Earth and the other for planets near it because of its gigantic size. Besides, even if it were to match the sun in size, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is a very giant star located in the constellation Orion, about 600 light years from Earth. Its gigantic size is one of its most striking components. It is multiple times greater than our sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This legendary size allows Betelgeuse to appear as a disk instead of a point of light when viewed through powerful telescopes. Unlike most other stars, despite its size, Betelgeuse is not the most massive star. Its mass ranges from about 12 to 19 times that of the sun. This variation in mass estimates is due to the challenges in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Still, even at its lower estimated mass, Betelgeuse remains a huge celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates constantly over time, with its brightness ranging from magnitude 0 to plus 1.64. Comparison: a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star at its brightest. Betelgeuse can be up to 1,000 times more brilliant than our sun. This fluctuation is due to its pulsations, intermittent expansions, and contractions caused by internal within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for months, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct red color typical of red Giant stars nearing the end of their life cycles like other red giants. Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It displays dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive, vigorous star, but it will eventually meet its end in a spectacular supernova. Betelgeuse is an enormous star nearing the end of its life, and its possible fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a cosmic explosion, a catastrophic blast that marks the death of a massive star. The power of a supernova is strong enough to briefly outshine an entire galaxy. This phenomenon could potentially send shock waves through space, and it's possible Betelgeuse will undergo such an explosive and very soon. This fate, while not immediate, is something scientists are carefully studying, hoping to learn more about the future of stars and the evolution of the universe. As Betelgeuse nears the end of its stellar life, astronomers are paying close attention to its behavior. The star is expected to eventually go supernova, an explosive event that will result in the ejection of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a cataclysmic event in a star's life cycle, signaling the final stages of its evolution. Betelgeuse's eventual supernova could be visible from Earth without the aid of a telescope, given its immense brightness and relative proximity. This explosion would release vast amounts of energy, creating heavy elements like iron and nickel, which are essential to the formation of planets and other celestial bodies. These elements would be scattered throughout the cosmos, enriching the interstellar medium and contributing to the creation of future generations of stars and planets. Interestingly, scientists have been able to detect strange fluctuations in Betelgeuse's brightness in recent years, leading to speculation that the star could be on the brink of a supernova. However, despite these variations, it's difficult to predict exactly when the star will explode. Some researchers have suggested that Betelgeuse could go supernova within the next 100,000 years, a short span in the life of the universe, but still too far away to pinpoint accurately. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its red capabilities allow scientists to study the star's outer layers and magnetic fields in unprecedented detail. The JWST findings have helped confirm the star's ongoing changes, including its irregular brightness and potential instability. These observations offer valuable information about the processes leading up to a star's death, providing a better understanding of stellar evolution. Betelgeuse's death will have far-reaching implications for the universe. The supernova shockwave could potentially trigger the formation of new stars in the surrounding region, furthering the cycle of stellar birth and death. Additionally, the elements produced by the explosion will spread throughout space, contributing to the building blocks of new worlds in the grand scheme of cosmic evolution. The death of Betelgeuse will not only mark the end of one of the most massive stars we can observe, but also pave the way for the next generation of celestial objects. Although we won't be around to witness the star's final moments the study of Betelgeuse provides valuable insights into the life, cycles of stars, and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death, and it offers a glimpse into the fate of other stars that share similar characteristics. In the future, scientists hope to continue studying Betelgeuse with the help of advanced technologies and space observatories. The data gathered from the star will continue to shape our understanding of astrophysics, helping us unlock the mysteries of how stars evolve and what their explosive deaths mean for the universe as a whole. Betelgeuse, as a massive and dynamic star, is a key piece of the cosmic puzzle, and its eventual demise will be one of the most fascinating events in the life of our galaxy. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing and evolving. New stars are being born all the time, and the energy released by supernova like Betelgeuse's will ensure that the cycle of life and death in the cosmos continues. The legacy of Betelgeuse will live on not only in the elements it produces, but also in the knowledge it has provided to generations of astronomers and stargazers. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe, understanding more about the forces at work in the cosmos and our place within it. As we learn from these celestial giants, we are reminded of the vastness and complexity of space and the awe-inspiring processes that shape the universe we call home.